through the slides, and after that, next week we will have another session next week, right? So next week will be the practicals. Okay. If you have anything, questions, or you don't understand, you can write in the chat. Okay. If you wanna say something, then feel free to unmute yourself. So may I reconfirm that you can see my slide and you can hear my voice clearly?
Yes, doctor.
Yes, doctor.
And the sound of constructions is not bothering you, eh? All right.
Doctor, can you and maximize your slide?
All right. Okay. Right.
All right. Thank you.
Okay. All right. So this is analysis of variance lecture. Okay, analysis of variance lecture. So what is ANOVA? Analysis of variance is also known as ANOVA. Okay, analysis of variance. So it is a collection of statistical models. Okay, statistical models. So there is statistics, then there are also models. Okay, so there are statistics that are not models, but ANOVA is one model, and this model belongs to statistics. Okay, so that's why we call it as statistical models. So what we do with ANOVA is that we estimate. Okay, estimate the variance. Okay, the variance or the variations among and between groups. Okay, for example, you have group 1, maybe Malay, group 2 Chinese, group 3 Indian, group 4 others. So and then you measure height. Okay, height, tinggi. All right. So this will be the height for Malay. This will be the height for the Chinese, and this will be the height for Indian. This will be the height for what others. Okay, and this is the distributions. Okay, distributions of height, distributions of height, distributions of height, distributions of height. So and so this distribution means that the variations. Okay, there are variations of height for Malay, variations of height for Chinese, variation of height for Indians, and variations of height for others. So by comparing the variations between group, you be able to say if the group's height or if height between groups are different or not. Okay, so that's why we call this as analysis of variance. So we analyze the variations. Okay, analyze the variation. All right. So the question is, okay, since you learn about independent t-test, all right, where you can compare the mean between group 1 and group 2, group 2 and group 3, group 3 and group 4, why don't we just do independent t-tests? All right, why don't we just do independent t-tests? Right? Okay, why not doing multiple independent t-tests? The problem is that every time you do an independent t-test, you always get the type 1 error. Okay, for every analysis there will always be error. Okay, and that error we call it as type 1 error. And this error is usually set at 5%. So if we run two independent t-tests, so if one error is set at 5%, if one test is set at 5%, two tests will become 10%. Okay. So 5%, we can call this as, error, mistakes that you don't want to happen. Okay. So one time you have 5%, twice you have 10%, three times you have 15%. Okay. So it means that the more comparison you make, the bigger the error that you are going to commit. Okay. So this is the problem of why we don't compare between 1 and 2, 2 and 3, 3 and 4, because every time you do that, you will have type 1 error. So to cater for this one, okay, to minimize the chance of making error, then we do ANOVA, okay, analysis of variance. So analysis of variance will compare, or will see, or will test if there is statistically significant difference between the means of 3 or more independent groups. Okay. So for example, here we have 1, 2, 3, 4. Okay. So whenever we have 3 or more groups, we do ANOVA. Okay. If there are only 2 groups, we do independent t-test. Okay. All right. So again, when we have 3 or more groups to compare, what do we want to compare? We want to compare the variation. Then we do analysis of variance, and this group should be independent. Okay, should be independent. All right. So what test does it do? No, what does the test do? Okay, sorry for this one, right? What does the test do? So one-way ANOVA, okay, there is one-way ANOVA, there is two-way, three-way, so on and so forth. But for the time being, we will learn about one-way ANOVA, okay? One-way ANOVA compares the means, okay, between the groups you are interested in, and it will determine if any of those means are statistically different from one another. For example, you have this is the mean, let's say BMI, body mass index. Okay, body mass index. So this is the mean body mass index for Malay. This is the mean body mass index for Chinese. This is the mean body mass index for Indians. Okay, so on and so forth. So we have 1 group, 2 group, and 3 groups. So the null hypothesis is that all groups have similar means. Okay, all groups have similar means, and the alternative hypothesis is that at least there is one pair that have different means. Maybe between group 1 versus group 2, group 2 versus group 3, group 1 versus group 3, so on and so forth. So the null hypothesis for ANOVA is that all groups have same means, whereas the alternative hypothesis says that at least one pair of the group means are different. All right. If you have any questions or any problems, just let me know, because I can't see the chat box at the moment because because of the slideshow. Right. So mu here refers to the group mean. Okay, the group mean. For example, we have a sample of 40 Malay students. So we measure the body mass index. So this will be the mean for the Malay group. This will be the mean of BMI for the Chinese group. This will be the mean of the BMI for the Indians group, so on and so forth. Right, what is that? So the alternative, the null, NULL, okay, the null hypothesis says that all the groups have same means, okay. So the means of BMI for Malay is similar to Chinese. The mean body mass index for Chinese is similar to Indians. The mean body mass index for Indians is similar to Malay. So the null hypothesis says there is no difference in the body mass index between groups in this research, for example. Okay. All right. And to say whether there is difference or not, then we will perform what we call as the one-way ANOVA test. Okay, one-way ANOVA test. In one-way ANOVA test, there is a test that we perform, which is the F test. Okay, F. Okay, the word F. If the F test is big and the p-value for the F test is less than 0.05, then we will reject the null hypothesis. Okay, if the F test is big and the p-value is less than 0.05, we will reject. Okay, we will reject the null hypothesis. Okay, we will reject the hypothesis that says all groups have same means. Instead, we will say not all groups have same means. Okay, so if the F test is big and the p-value of the F test is less than 0.005, then we reject the null hypothesis, and then we say there are at least two group means that are statistically significant. Okay. In all statistical tests have assumptions. All right. All statistical tests have assumptions. Okay. The first assumption is that the dependent variable is normally distributed. Okay. The first assumption is that the dependent variable, for example, body mass index, the body mass index must be normally distributed in each group. Okay. If you have a group Malay, Chinese, and Indian, it means that the body mass index must be normally distributed for Malay. Body mass index must be normally distributed for Chinese, and the body mass index must be normally distributed for Indians. For each group, the body mass index must be normally distributed. Okay. Secondly, the variance. Okay, the variance. If you remember, the variance is the square of the standard deviations. Okay, so the variance must be homogeneous. Okay, the variance must be homogeneous. It means that the variance of BMI is similar to the variance of BMI in the Chinese. The variance of BMI in Chinese is similar to the variance of BMI in Indians. The variance of the body mass index for Malay is similar to Chinese and Indians. Okay, so that's the second assumption. The third one is the independence of observations. Okay, independence of observations. This one cannot be tested. Okay, cannot be tested because this is something that you have to ask yourself, or you have to ask who collected the data, how they collect the data, um, how did they do the sampling. Okay, how did they do the sampling? Okay, for these assumptions to be valid, the observations must be independent. Okay, the observations must be independent, right? It means that um, you know, observation number 2 will not affect observation number 3. Observation number 3 will not affect observation number 4. So that's what it means by independence of observations. So this is the F test. Okay, this the F test. The F test is the test that will compare the variations between the groups. Okay, so remember, we are now learning about analysis of variance. Okay, so we analyze variance. So variance in between groups. So how to compare the variance? We compare that using the F test. Okay, F test. So the F test, the F value equals the variance between treatments divided by variance within treatments. Okay, so the F test equal mean square of treatments divided by mean square of error. Okay, so so you can read more about the F test. Okay, you read on your own. After you, so you have ANOVA, and then to test the variations in ANOVA, you use F test. And if F test is big enough and the p-value is less than 0.05 from the F test, which means that we reject the null hypothesis, which means that the means of the groups are not all the same. There are groups with different means. So what we need to do next is the post hoc test. Okay, the post hoc test. So we perform the post hoc test after we find a statistically significant effect in ANOVA. Okay, so if the F test is significant, what do we mean by significant? The p-value of the F test is less than 0.05. Then we will do the follow-up test, which is the post hoc test. Okay, post hoc test. So from the post hoc test, we can see which pair, okay, which pair, PAIR, of the groups are different. Is it between Malay versus Chinese, or Malay versus Indians, or Chinese versus Indians? Or is it all the three groups are different? Okay, so that's the use of the post hoc test. All right. In ANOVA, there are different models. Okay, there are different models. First one, we have the fixed effect models. Okay, fixed effect models. Number two, we have random effect models. And number three, mixed effect models. Fixed effect models means, okay, fixed effect models mean um, fixed effect model mean the groups that we compare are not random. Okay, it means that we purposely choose group 1, group 2, and group 3. For example, okay, group 1, group 2, group 3, and group 4. In random effect models, um, the choice of group 1, group 2, group 3 are done randomly. It means that you go to the population, you choose randomly group 1, group 2, and group 3. Maybe you have 100 group 1 and you took 20. Maybe you have 100 in group B you took 30. Maybe you have 100 in group C and you took 50. Okay, so random effect models. In mixed effects model, you have a combinations of both fixed and random effects. This concept of fixed, random, and mixed models are a little bit advanced for you, but I encourage you to go and read on your own. Okay. All right. So types of ANOVA based on design. Okay, this is design of the study. So just now is the types of ANOVA based on models, and this is types of ANOVA based on the design of the study. Okay, number one, you have one-way ANOVA. Okay, one-way ANOVA. One-way ANOVA is very commonly done. So basically, you are comparing the means between three or more groups. Okay, you are comparing means between three or more groups. Secondly, you have factorial ANOVA. Factorial ANOVA, where you compare the interaction between groups. Okay, you are comparing interaction between groups. Okay. Thirdly, you have repeated measure ANOVA. Repeated measure ANOVA, where you take data repeatedly. For example, you are taking the body mass index for group A 5 times. Okay, this month, next month, month 3, month 4, and month 5. Okay, so that is repeated measure ANOVA. It means that data that you take comes from repeated measurement. And the last one is multivariate analysis of variance. Multivariate analysis of variance if there is more than one response variable. Okay. Um, that's all basically the lecture for this morning. Okay. I just want you to get a rough idea about ANOVA. Soon after this, I will provide you with some learning materials. And next week, we will do practicals. Okay, we will do practicals. So in the notes that I'm going to give to you soon after this, there will be some references for your own learning. That's number one. Number two is some the software or where you can go to do the practicals. Okay, and because the practicals that we are going to use is based on our software, it is not based on SPSS. Okay, right. So yes, soon, maybe today or maybe tomorrow, I'll will send the note. The note will contain the some references that are important for you to read, and secondly, the note will contain the instructions to do during practicals. Okay, how to do the practicals in the note. All right, I think that's all. Any questions?
Doctor,
Yes.
for ANOVA, the test for equivariances, is this the same for t-test?
No, t-test used t-test used t-test. Okay, independent t-test use t statistics, whereas ANOVA use f statistics.
I mean the for checking the assumption of equivariance.
Yes,
Is it the same?
you can use the same Levin's test, or you can use some other tests, Levin's and a couple more of tests for analysis of variance. Does that answer your questions?
Yeah, thank you, doctor.
All right.
Doctor, I got a question regarding, for exam.
Can you say your name? Can you say your name, please?
Ramesh.
Yes, Ramesh. Yes.
Okay. For exam purpose, what kind of questions normally come from this ANOVA topic?
Simple questions. So specifically, it's not going to be hands-on. So I'm going to ask you maybe to some concepts of ANOVA, maybe how to do ANOVA, even though you don't do you don't do hands-on for exam, but maybe
steps.
maybe steps to do analysis in the software, the general step, and maybe
Requirement.
Interpretations and checking of ANOVA models. Is that all right, Ramesh?
Okay, thank you very much, doctor.
All right. right. Any more questions? Okay, I'll give you 1 more minute. If you have questions, say your questions. All right. So,
Impression tu full report.
right. So I guess there is no more questions. I think the lecture is recorded, right? So so if you want the recording, you may ask from. I'm not sure who's recording the lecture. Okay, tak apa. So is that all? So no more question, eh?
No, doctor.
No question. All right. So next session is next week, right? Same time. Okay then. So have a nice day. Stay safe. 2 weeks. 2 weeks. All right. 2 weeks. 2 weeks. Okay. Right. Right. If you have questions, you can email me. Very concise, my note. Are you sure? All right. Okay then. So this is the boring part, the lecture part. The practical part is more interesting. Okay, more interesting. So any one of you who has experience using R software? That's my last questions.
For me, I don't know. No,
Yeah, only
No,
FPSS.
Yeah.
No,
Same.
then that's good. So this is gonna be very exciting then. Okay, so all right then. So everyone, yep.
do we have to install the R software?
No, everything will be done on the cloud.
Okay, thank you.
All right. So okay then. Have a nice day. Stay safe and see you in 2 weeks. All right. Okay. Bye. Assalamualaikum.
Thank
Thank you,
you.
doctor.
Thank you.
Thank you, doctor.